Hello everyone. In today's lecture, we will discuss how to calculate the annual inventory cost for an EOQ system. Let's start with an example problem. A store sells a product that has a constant daily demand of 5 units per day. The store places a replenishment order of 50 units to its supplier every 10 days. The unit purchase cost is $130 per unit. The supplier sends each order in one shipment. The order lead time is 4 days. It costs the store $75 to process, receive, and unpack a shipment. The cost of shipping the product in the inventory is $15 per unit per year. The store sells the product for $240 per unit, and the store operates 250 days a year. We are interested in calculating three different things. First, the total annual cycle inventory cost for the store. Then the optimal order quantity for the store. And finally, the annual purchasing cost for the store. It is always a good idea to summarize all the given information so we can list it one by one, the given data and information like daily demand, order quantity, length of the inventory cycle, unit purchase cost, order lead time, setup cost, unit holding cost, unit selling price, and days per year. Next, we will calculate first the annual setup cost. The annual setup cost or the annual ordering cost is D divided by Q times S. So capital D is the annual demand rate, which can be calculated by multiplying the number of days per year times the daily demand. Thus 250 times 5 is 1250 units per year. Then the annual setup cost is 1250 divided by 50, which is the order quantity, times 75, the setup cost per order. Then the annual setup cost equals $1,875 per year. Next, we will calculate annual holding costs. The annual holding cost is equal to order quantity divided by 2 times unit holding cost. As you remember, order quantity is 50 units and the unit holding cost is $15 per unit per year. Then the annual holding cost will be 50 divided by 2 times 15 equals $375 per year. The annual inventory cost, which is also called the total annual cycle inventory cost in the textbook, is simply the sum of the annual setup costs and the annual holding costs. Then AIC will be equal to $2,250 per year. This is the answer for the first question. Next, we will calculate the optimal order quantity according to EOQ model. As we know, in order to minimize the annual inventory costs, the store should use what is called the optimal order quantity with the notation Q star. So Q star is equal to square root of 2 times yearly demand times setup cost divided by unit holding cost. So by plugging the right information, it will be a square root of 2 times 1,250 times 75 divided by 15 equals 111.8034 units. Note that Q is larger than the current order quantity of 50. So this signifies that the current order quantity of 50 is far from the base order quantity of 111. Now we can calculate what is the optimal annual inventory cost if the company, the store, uses the optimal order quantity. Using the same formula for ASC and AHC, the asterisk is attached to signify that those costs are optimal costs because we are using optimal order quantity. And it turns out that the optimal annual inventory cost will be $1,677.051 per year. It is important to note that it is not by accident the optimal ASC is equal to the optimal AHC. So this is the property that if we use the optimal quantity Q star, then the optimal annual setup cost will be equal to the optimal of annual holding cost. As you can see, the 1,667 is lower than the previous cost. Finally, we will calculate the annual purchase cost. It is important to realize that annual purchase cost, APC, has nothing to do with the EOQ model. It's simply because the store knows the yearly demand is 1,250 units. Consequently, the store must purchase a total of 1,250 units a year in order to satisfy the yearly demand. So the annual purchasing cost is simply yearly demand times the unit purchase cost, which equals $162,500 per year. In conclusion, if the store uses the order quantity of 50, the store has the annual inventory cost of $2,250. $250 per year. But if the store uses the optimal order quantity of 111.8 units, the store has a lower annual inventory cost of 1,677.05 per year. In fact, this is the lowest cost according to the EOQ model. Finally, we have seen that the annual purchasing cost is $162,500 per year. This concludes the lecture today. Thank you.